In this video, we will illustrate the main features and potentialities of the system. We will show what are the processes that APMS performs to do a complete and accurate technical analysis and diagnostic. More precisely, we will prevent technical issues related to the machine, with great criticality within the ecosystem. Often, you have problems in a machinery that caused originally by other machines that are part of the same circuit. The system informs us, via an automated email, of the current situation of the circuit. This email is mainly divided into 4 points. Technical diagnostic result. In the first point, the system notifies us of a start of cavitation in the lube oil pump 2 component. Through the application we can note that various sensors of the pump have gone into alarm. The critical level of these alarms can range from yellow, out of optimal, to red, warning, and purple, critical, the more serious cases of the three. On this screen, we can see how the system take into account not only the condition data but also the process data of the monitored system. Here, for example, we see vibration data, measured on bearings, and process data such as temperature, current and speed of the electric motor. Technical symptoms. In the next step we identify the symptoms. Within this point, we can describe the technical symptoms, which have allowed us to understand that our component is subject to cavitation. To get a better understanding of the problem, we can monitor the time and frequency of the sensors that have triggered the alarms. These types of data are used automatically by our software, but are also available and easily interpreted by experienced technicians and engineers. The system also informs us of the root cause that created the specified anomaly. Root causes analysis. Thanks to the holistic monitoring of the circuit, by correlating the process and condition data all together, we are able to understand the initial cause that has created the pump cavitation. As described, the cavitation is due to lowering of the incoming pressure. But not only. We are told that this problem is caused by another component outside the pump, the filter. The filter shows a differential pressure that causes a pressure drop on the exit. The system further deepens its analysis and goes from identifying the origin of this pressure drop, which appears to be caused by a partial filling of the filter, due to the presence of impurities in the oil. At this point, the system proceeds to check the oil sensor, to determine if there is a presence of ferrous elements. The oil sensor not being an alarm, the system deducts that the impurity contained in the oil are due non-ferrous element. Technical prescriptive advice. As a final piece of information, the system gives us a suggestion of what action should be carried out by the operator to solve the identified technical anomaly. The technical prescriptive advice is a very important step for the technician, as it can save time and efforts in problem solving. This point describes the suggested actions to perform in order to bring remedy to the technical issues identified predictively. At the end, we understand that the oil cleanliness is the primary cause of all the chain of events monitored. To demonstrate how the system eliminates false positives by correlating multiple sources of data and inputs, just think that if we had not taken into account the data describing the filter and the oil conditions, the root cause analysis would have identified the impeller as being the cause of the pump cavitation. This would have resulted in a machine downtime, and in an unnecessary corrective maintenance task on the pump. While this technical issue can be easily addressed by simply changing the filter and the oil,